Okay, so we have the fourth basic machine, the inclined plane. You understand? Okay. The mechanical advantage for inclined plane, don't forget that this is how the inclined plane look like. Just like a right angle triangle, you understand? This is a plane or a smooth surface. Now, the mechanical advantage of an inclined plane is equals to load all over effort, you understand? But the velocity ratio is different. The velocity ratio is equals to 1 all over sine theta. I'm going to explain. You just have to pay attention, you understand? I'm going to explain. Do you know the meaning of inclined plane? The plane that has an angle of inclination is what we call inclined plane. You understand? The plane that has an angle of inclination is what we call inclined plane. You know, when you say something inclined, for example, you can say that a ladder inclined at an angle of maybe 50 degrees. You understand? That means that the ladder is making an angle of 50 degrees to the vertical wall that it rested on by 50 degrees. You understand? That is it. So when we talk about inclined plane, the plane that is inclined with an angle is what we call inclined plane. You understand? So that is why we have theta. Theta is the angle of inclination. You understand? The plane that has an angle of inclination is what we call inclined plane. Theta is the angle of inclination. Now, there is something that I want you to know. When we are dealing with velocity ratio of an inclined plane, the velocity ratio depends on the angles of inclination. You understand? If the angle is inclined vertically, you understand? Pay attention. If the angle is inclined vertically, then the velocity ratio will be 1 over cos theta. You understand? The velocity ratio will be equals to 1 over cos theta. This is if the angle is inclined vertically. Okay? If the angle is inclined vertically. Now, if the angle is inclined horizontally, the velocity ratio is 1 over sine theta. Do you understand? So those are the two conditions. Pay attention to the question, okay? In the question you'll be notified maybe the angle is inclined vertically or horizontally. Now, depending on the question, you can either use this formula or this formula. You understand? Okay, so let's look at work example under inclined plane. An inclined plane at an angle of 60 degrees to the vertical is used as a simple machine. A force E is used to push a load of 120 Newton uniformly up the plane at efficiency of 50%. Determine its velocity ratio and determine the magnitude of E. Don't forget that E is the force. You understand? The effort. You understand? That is E. Okay? So let's start by writing out the information that you are given in the question. We are given that the inclined plane is inclined at an angle of 60 degrees. Angle, let's call it theta, equals to 60 degrees. And the question will proceed. It is inclined at an angle of 60 degrees to the vertical. You understand? So you can see now, that's what I'm trying to tell you, that we can have the angle of the inclined plane inclined at vertical, or it can be inclined horizontally. You understand? So now this question says it is inclined vertically. Okay, so a force E is used to push up the load of 120 Newton. Force. We don't know the force, but we know the load. The load is 120 Newton. You understand? Okay, let us proceed. Of the plane at efficiency of 50%. Efficiency equals to 50%. You understand? Okay, we are asked to determine the velocity ratio and the magnitude of the magnitude of E. E there is effort. You understand? Effort is also a force. The effort is the force applied to push up the load. You understand? So effort is also a force. Now, how do we determine the velocity ratio? Don't forget that velocity ratio, the relationship between efficiency velocity ratio, and mechanical advantage is that efficiency, which is equals to mechanical advantage all over velocity ratio. You understand? But we cannot determine the velocity ratio without knowing the mechanical advantage. And mechanical advantage is what? Load all over effort. You understand? So, and you cannot determine the mechanical advantage as well without knowing the effort. Do you understand? Okay? So, the first thing to do here is that we are going to determine the velocity ratio. You understand? Because the angle is inclined vertically, velocity ratio will be equals to 1 over cos theta. You understand? Please pay attention. Because the angle is inclined vertically, the velocity ratio will be what? 1 over cos theta. So we can determine the velocity ratio. Velocity ratio equals to 1 over cos theta. Theta is what? 60 degrees. That will be velocity ratio will be equals to 1 over cos 60 degrees is what? 0.5. You understand? Cos 60 degrees is 0.5. So 1 over 0.5 is 1 over 0.5 equals to 2. You understand? So that is the velocity ratio. Now, how do we determine the effort? The magnitude of the effort. To determine the magnitude of the effort, all you have to do is that we just have to use the formula of efficiency. You understand? Efficiency is mechanical advantage all over velocity ratio. Now, the velocity ratio is what? 2. So, the efficiency is what? 50%. So, I'm going to get the mechanical advantage, then I'm going to use the formula of mechanical advantage, which is load over effort, to determine the effort. You understand? Just pay attention, okay? Now, let us proceed. Don't forget that efficiency is what? Mechanical advantage all over velocity ratio. And the efficiency that we are given in the question is what? 50%. So, 50% equals to mechanical advantage all over velocity ratio. Velocity ratio is what? 2. So 50% all over 2. Do you understand? 50% is what? 50 over 100. So I'm going to have 50 all over 100 equals to mechanical advantage all over 2. Do you understand? Okay. Now take the cross product. That is, we are going to cross multiply. So I'm going to have mechanical advantage multiplied by 100 is equals to 2 multiplied by 50. Do you understand? Okay. So mechanical advantage equals to 100 all over 100. You understand? Because mechanical advantage multiplied by 100. That is what? 100. I divide both by 100. 2 times 50 is what? 100. I divide both by 100. So 100 will cancel this 100, and this also over 100. You understand? That's what I did. This 100 will cancel this 100. So I'm left with this. Do you understand? Okay. 2 times 50 is what? 100. Now, that means mechanical advantage is equals to 1. Do you understand? Now, having gotten the mechanical advantage as 1, we can get the effort. You understand? Because mechanical advantage, please pay attention. Mechanical advantage is what? Load all over effort. You understand? Now, the load is what? 120 Newton. So, mechanical advantage equals to 120 Newton all over effort. Now, mechanical advantage is 1. Do you understand? So, I'm going to have 1 equals to 120 all over effort. You understand? So, if I take the cross product, effort equals to 120 Newton. You understand? So, that is the effort required to lift up. That is the effort required to push a load of 120 Newton uniformly up the plane. Do you understand? Please, this is simple. All you have to do is just learn how to interpret question. Having gotten the mechanical advantage here, I substitute it into this formula. Mechanical advantage is 1. So, I've been given a load of 120 Newton. So, I take the cross product. This is what I did. 1 equals to 120 all over E. Now, this over 1, if I cross multiply, I'm going to have E multiplied by 1 is E. 1 multiplied by 120 is what? 120 Newton. You understand? That's how I got 120 Newton here. Do you understand? Okay? So that is the solution to the problem on inclined plane. You might come across questions in your exam that will say that the angle is inclined horizontally. What will be difference is the velocity ratio. You understand? All you have to do is that just master when you are going to use VR equals to 1 over sin theta and VR equals to 1 over cos theta. You understand? So if the angle is inclined horizontally, let's say this. If the angle is inclined horizontally, this will be VR equals to 1 over sin theta. I'm not going to use VR equals to 1 over cos theta. Do you understand? Okay, I have this test question for the previous set, 2023, 2024, you understand? Okay, I have a question 2B is on inclined plane, so I want us to go through it, you understand? Okay, an inclined plane at an angle of 30 degrees to the vertical is used as a simple machine. A force E is used to push a load of 130.5 Newton uniformly up the plane at efficiency of 85%. We are asked to determine the velocity ratio and the magnitude of the effort. Okay, don't forget that the angle in the question, the angle is inclined vertically, you understand? And I told you that if the question says that the angle is inclined vertically, we're going to use VR equals to what? 1 over cos theta. So let's start by writing out the information that we're given in the question. Theta equals to what? 30 degrees, you understand? That is vertically. 30 degrees vertically, okay? And then we're given that a force E. So we have the effort. Effort is not known. We don't know the effort. That is part of the parameters that we're asked to calculate. You understand? Okay? And we have the load. The load is what? 130.5 Newton. You understand? Okay? Then we have the efficiency. The efficiency in percentage is what? 85%. You understand? We are asked to determine the velocity ratio and the effort. The velocity ratio, we don't know it, and we are asked to determine the effort. Don't forget that, let's say the load is in kilogram. Please pay attention. Let's say the load is in kilogram. You first have to convert to what? To Newton by multiplying the load by 10, you understand? Depending on the acceleration due to gravity that you are given in the question, you understand? So, but the load is in Newton now, so you can just proceed to calculate your velocity ratio, okay? Now, because the angle is inclined vertically, velocity ratio equals to what? 1 over cos theta, you understand? Like we did in the previous question. So, velocity ratio equals to 1 over cos theta, okay? Velocity ratio equals to 1 over cos 30 degrees, which is what? 1 over 0.8660. Now, 1 over 0.86, please pay attention, cos 30. So 1 divided by 0.8660, that will give us 1.15, okay? That is 1.15. I'm using 2 decimal place. So that is 1.15. The velocity ratio is 1.15. Now, having determined the velocity ratio, we can determine the mechanical advantage. Then from there, we can calculate the effort. You understand? The mechanical advantage is what? Is unknown. And we have been given that the efficiency is what? 85%. And we know that efficiency equals to what? Mechanical advantage all over velocity ratio. You understand? Mechanical advantage all over velocity ratio. Now, efficiency has been given at 85%. So I'm going to have 85% equals to mechanical advantage. Mechanical advantage is what I want to determine. So I'm going to proceed as MA over 1.15. You understand? Okay? Efficiency is 85 all over 100 equals to mechanical advantage all over 1.15. Now take the cross products. I'm going to have mechanical advantage multiplied by 100 equals to 85 multiplied by 1.15. You understand? So mechanical advantage equals to, you see, okay, don't let me skip any step now. Divide all by 100, divide this by 100, you understand? This 100 will cancel this 100, so I'm left with what? Mechanical advantage equals to 85 multiplied by 1.15. That is 97.75, okay? 97.75 all over 100. Oh, this is amazing. Okay. 97.75 all over 100. Now, this is point is not negative, okay? So the mechanical advantage here equals to 97.75 divided by 100. Okay, that will be 0.097. Okay, you can put it 0.0977. Okay, 0.78 now. Let's approximate 0.0978. Okay, now having gotten the mechanical advantage at 0.0978, we can determine the effort. You understand? Because mechanical advantage, please pay attention. Mechanical advantage equals to load all over effort. You understand? Load all over effort. Now, mechanical advantage is 0.0978. 0.0978 equals to load. The load is what? 130.5 Newton. So I'm going to have 130.5 all over effort. You understand? So here I'm going to have let us cross multiply. I'm going to have E multiplied by 0.0978 equals to 1 multiplied by 130.5. That is what? 130.5. You understand? So I'm going to divide also by 0.0978 this over 0.0978. You understand? So effort equals to 130.5 divided by 0.0978. That is 1334 Newton. Okay, 1334.35 Newton. You understand? So the effort required to push the load of 130.5 up the inclined plane is 1334.35 Newton. Do you understand? So those are example of questions that can come out in the exam on inclined plane. You understand? So don't forget that inclined plane is also one of the basic machine that we use on the farm. Okay, so you can see now. So anytime you come across question on inclined plane, depending on the structure of the question. So let's proceed to another basic machine. Okay,
to watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.